Welcome to section 4.1, graphing quadratic functions. Here we're going to be giving quadratic functions examples, and we're going to be working on finding towards axis of symmetry, vertex, the Y-intercept, if it's going to be maximum or minimum, if it opens up or down, and what's the maximum or minimum value. Alright, in our first example, we have f of x equal 2x squared plus 12x plus 13. When you're given a quadratic function, it's always best to identify your a, b, c value. Now, again, a is just the number in front of x squared, b is just the number in front of x, and then c is just a number by itself. So my a value is simply 2, my b value is simply 12, and my c value is simply 13. So, first we're going to find the axis of symmetry, or also known as AOS. So, I'm going to write AOS. Now, if we were to go back, the formula for AOS, axis of symmetry, is simply x equal negative b over 2a. So, basically I'm going to write the formula, but remember, there's a negative. I'm going to simply plug in 12 for b and 2 for a. So 12 into b, and then 2 into a. So again, I plug in 12 for b, and then plug in 2 for a. Next, I'm going to simplify. I still have that negative, 12 on the top, 2 times 2, which is 4. I can simplify this fraction. So negative 12 divided by 4 is negative 3. Alright, so axis of symmetry. Next, we're going to look for vertex. Vertex is a coordinate point x comma y. So let me write it out. Vertex is x comma y. Now, technically, we already know our x value because that comes from the axis of symmetry. So here, let me write it again. We did all this work to simplify where x is negative 3. So if x is negative 3, we already have our half of the vertex. So negative 3 comma y. So in order to find the y value, I simply going to plug in the x value into this quadratic equation. So f of negative 3 simply mean that it's going to be 2 times negative 3 squared plus 12 times negative 3 plus 13. So in order to find the y value, I gotta simplify this. So using PEMDAS, 2, if it's negative 3 squared, first I'm going to write it out twice because it's square to make it easy and visually see it. Alright, now the reason I like to write it out is so that I can see that it's a negative 3 times negative 3. It helps a lot if the power is to the third or cubic, which we will be working on that next semester. Alright, so it's going to be the exponent, negative 3 times negative 3, that's positive 9, so it's going to be 2 times positive 9. And everything else will stay the same. So, working from that, I'm going to multiply all the numbers. So 2 times positive 9 will be positive 18. Positive 12 times negative 3 will be minus 36 plus 13. Alright, so I'm going to go from left to right. 18 minus 36, that will become negative 18 plus 13. And then negative 18 plus 13, that would be negative 5. So our y value, or f of negative 3, will be negative 5. So our vertex will be negative 3, comma, negative 5. So that's going to be our vertex. So let me underline vertex here. And then this is our answer. Our axis of symmetry is x equals negative 3. So to review with those two parts, axis of symmetry, x equals negative 3, is connected to vertex because we already have our x value, meaning half of the vertex. To find a y value, simply plug it in, work out slowly. Again, I worked out my square and then did the multiplication. Alright, next we're going to be talking about the y-intercept. So I'm going to erase to make more room. So in order to find your y-intercept, it's always in the form, a coordinate form. Remember, it's going to be x comma y. And I stated in the previous video that x is always 0. Now, in the previous video, I said that you would have to plug in 0 into all the x's in order to find a y-intercept. But the fastest way is the y-intercept is always the c value. So our y-intercept is going to be at 0, 13. So that was it. That's all you have to do for a y-intercept. Is simply right as a coordinate point, x is always 0, our y value is always c. So 0, 13. Now sometimes you might see where we write it as y-intercept equals 13, which is fine. But remember, when you're graphing, we're going to give it in coordinate points. X is 0, y is 13. So that's our y-intercept. Alright, next we're going to talk about if this is going to open down or up. Now, in this quadratic function, it's going to open up. Now, if it opens up, that means there's going to be a minimum. So I repeat, if it opens up, there's going to be a minimum. Now, if there is a minimum, the minimum value is easy. Now, minimum, or min for short, will be the y value of the vertex. So, y equals negative 5. So that's the minimum value. That's it. So it's very important that you find the axis of symmetry and then the vertex. It all connects it, so axis of symmetry will help you find vertex. Y-intercept is going to be separate. Y-intercept is just the c value. Now, to determine when it opens up or down, we're going to talk about that after our second example, but it will tie into our a value, so keep that in mind. Now, if it opens up, there's going to be a minimum. Minimum, or the minimum value, y equals negative 5, it's connected to the vertex. So, once you find your vertex, you can already find your minimum or maximum value. But in this example, it's minimum. So if you were to determine the minimum value, look at the vertex and look at the y value. In this case, it's negative 5. And so that's pretty much what I need from you to do when given this equation: axis symmetry, vertex, y-intercept, determine if it opens up or down, determine if it's a minimum or maximum, and then determine the minimum or maximum value. In this case, it opens up, therefore it's a minimum. In order to find minimum value, look at the vertex, y equals -5.